Hello, everyone, and welcome to this session on how BMW, Intuit, and Morningstar are transforming with AWS and Amazon Athena. Thank you all for attending, and it's really great to be here with all of you in person. So my name is Shivika Verma, and I'm a product manager with Amazon Athena. We'll also have presenting with us today Jens Kohl, who is the head of offboard architecture with BMW, Ravi Palala, who is chief architect at Intuit, and Cynthia Pekron, who is a head of product management at Morningstar. So let's get into a quick agenda. So I'll do an introduction, and then we'll hear about some exciting initiatives that are all powered by AWS and Athena from our customers. And these will be presented by Jens Kohl, Cynthia Pekron, and Ravi Palala. And then we'll have a quick summary and Q&A. So let's get into it. So we're here to talk to you today about Amazon Athena. We want to give you a feel of how, we want to directly give you a feel how AWS and Athena are powering businesses to revolutionize. So to set some context for today, I want to start by talking about how the cloud has changed the way many of us do business. We store more data today than ever before. Many of you are storing terabytes, if not petabytes, of data. And this is all coming from sources such as what you see here. This has led to the need for a modern data strategy. So the modern data strategy is enabled by a set of technology building blocks that you can see here. These allow you to manage, access, analyze, and act on data. They provide you multiple options for connecting to data sources. They empower your users to run machine learning and analytics, and manage who has access to your data. They provide you instant access and insights through business intelligence tools, and they break down data silos by giving you the best of both data lakes and purpose-built data stores. And they give you the option to store large quantities of data at low cost and in open and standard-based formats. AWS has the most comprehensive set of tools for this end-to-end data journey. So today, we'll zone into analytics and hear from some of our biggest customers how they're using AWS and Athena to achieve amazing outcomes for their customers, businesses, and industries. We'll get to see how Athena is playing a key role in their modern data journey. So with that, I want to talk a little bit about Amazon Athena. I want to call out a few things that make Athena great. So Athena is serverless and fully managed. It provides a simple and instant start and optimized runtimes for fast results. It allows for both interactive and advanced analytics, and it's open and flexible, allowing for multiple formats and compression types. It's also cost-effective, meaning that you only pay for what you use. So today's session, we'll get to see how the unique features of Athena, along with AWS, are allowing our customers to tap into the vast quantities of data that's available to them as they implement their modern data journey, which in turn is allowing them to accelerate insights, use data science and machine learning techniques to enhance customer engagement and experience, which in turn is allowing them to build products and services that are transforming their industries. So with that, let's get into it and hear from our customers on how BMW, Intuit, and Morningstar are transforming with AWS and Amazon Athena. Oops. So first up, we have Jens Kohl from BMW, and he's going to tell us about how BMW are using AWS and Athena to power their proactive care workflow. So over to you, Jens.
Thank you. Hi and welcome everyone. My name is Jens Kohl. I'm head of offboard architecture at BMW. And I'm really honored and privileged to present here what is the work or has been the work of several guys, including my own team. And what I want to show you is how we use AI to improve our service, to improve how we want to provide more benefits to our customers. And as said, I'm really proud of this, and I hope that after this short presentation, you will know that we not only build great cars at BMW, but also do some really great stuff in AI and co. All right, what is it all about? What is proactive care? Proactive care is kind of a paradigm change we have in the automotive industry. I mean, previously, I think most of you drive a car. The thing what we do is that we're more reactive. That is, I mean, a customer might have like a service demand. For instance, he doesn't have enough oil, water, or whatever in his car, and we just inform him by some lights in the vehicle, but we're not really telling him proactively what he could do. So this is something we really want to do. This is, as I said, a paradigm change that we go to them and inform him of what is really happening inside his vehicle. And the reason why we do this, because we are convinced that this is the customer expectation. If the customer buys a premium product, then he will also expect premium services. And the other reason why we do this is because we have the ecosystem for this. We're selling cars, I mean, in about every country in the world. We have a long-term relationship with dealers, vendors, sales guy. So we got the ecosystem to orchestrate this. So and the question is, it sounds easy, why haven't you been doing these things in the last years? Well, the reason is it's not really that easy as it might sound, because we have several challenges. And I'd just like to mention, starting with data. What you have to do in order to build this, you have to cover the whole life cycle of the vehicle, of each vehicle, and its hundreds of components over the whole life cycle. And we sell approximately 2.7 million vehicles a year, and each of those vehicles has several and hundreds of components. And each of you customers will hopefully drive our vehicle as long as possible, so you can extrapolate that we got the data over several years. And the data we're gathering, the data we're collecting is in a multi-model data format. We have like measurement values, which we sample up to a millisecond, I mean, some values a millisecond. We got like acoustic stuff, like sound of the engine, for instance, when you drive with the engine. And we also got like camera data, for instance, for our driving assistance systems. So these are multi-model data formats which are generated either in real time or event-based in case something happens. And the amount of data and our fleet is growing each year exponentially. So when the new class, which is our new vehicle series, comes out 2025, we will have we will increase the data we generate by a factor of 3. So this is the data we having. And the question is, where do you store the data? What do you do with the data? As I mentioned on the earlier slide, with this multimodal data formats, we got several petabytes of data, which is continuously growing. And in order to work with this, we have to access all this data almost instantly. So this is like kind of a challenge for our infrastructure. Then the offboard architecture, or the backend we're having, which runs quite intensively on AWS, receives at least, even on a low day, amount of requests of 1 billion per day. And the second thing, which is really, really a must for us, and there's like the laws for this are way more severe in Europe than in other parts of the world, the privacy laws. So we have to ensure that all the workflows with whom we handle data ensure or are compliant to data privacies. And this is a must for us. Okay, we spoke about the data, we spoke about the infrastructure. What do we do with the data? Machine learning, yeah, sounds quite easy. The problem we're having is with those service demands the customer might have, a lot of these are really not initially known at the beginning. I mean, if we produce a new car, if we launch a new car, there are several potential service demands of which we never heard before. We really do a lot to test. We really, invest a lot of money, time to get as much as possible, but still something is slipping through. And as you all know, probably sometimes what we perceive as a feature, the customer perceives as a bug. Yeah, thanks for laughing, but this was actually not. And so a lot of those labels are unknown. We do not know them at the beginning. And the second, even if we have them, we got a way bigger problem. I hope a lot of you guys have a BMW, own a BMW, so you know that it's not really quite common that you have like a service demand where you stand next to the street and have like a breakdown or so. So that means that for some of the service demands, it's highly, highly imbalanced data. Just trivially speaking, from machine learning, we talk about like a categorization or classification, and with a specific service demand, the relation between cars who might have a problem and the other cars is really, really not as you would expect it for normal machine learning. With normal machine learning, you'd like to have it 50-50, 60-40, something like this. But here, we're speaking about 99% of good versus, yeah. And this is like, for instance, if you just consider normal machine algorithms, an algorithm could just easily classify every vehicle as okay. So 100% okay, and he would just have an error rate of 1. Well, normal machine learning would say, hey, that's really great, but it doesn't really help you in our domain. So this is like basically one of the biggest problems we have. And the next thing is real-time monitoring. It doesn't really help you if you got the machine learning, but not really covering the fleet. So we have to monitor the whole fleet. That is 2.7 million cars a year, which we sell, over a life cycle of several years, so you can extrapolate it. It's something around 10, 12 million vehicles, which we could monitor. And the challenge is to predict the demand before occurrence. It doesn't really just take the instance of the oil level in the vehicle. It doesn't really make sense to predict it like 1,000 kilometers in advance, because then it's like Peter and the wolf. Sometimes the customer will not really reply if you say it too early. If you say it too last, it doesn't really help you, because then you gain nothing. So we have to find the right sweet spot to say, okay, this is, dear customer, this is something we should do. So if I might just paraphrase all those problems again, we got data, a lot of data, which we want to store on an efficient infrastructure, which we can scale. On this infrastructure, we do machine learning with the challenges I mentioned, and real-time monitoring, cover the fleet, and really just start to engage when it's the right spot, and not too early and not too late. So these are the challenges. And on the next slides, and of course you might have noticed that I was always doing some product information. So how would we solve this? First of all, infrastructure. We got like 2 big data lakes which we are using at the BMW Group. The one is the Cloud Data Hub, which has been presented last year already at reInvent by Simon Kern. And the next platform is the Connected AI platform, which will be presented by my colleagues Andreas Jochem and Lian Abt tomorrow at, I think, 2. So please have a look at this. It's really amazing what those guys are doing. But on this data platform, this is something I'd really like to mention in explicit detail, because it's really important for us. First, data privacy. We only use data from customers who opted in. So if you have a BMW, there's this menu which asks you, do you want your data to be transferred back to BMW? And only if you opt in, we get the data from you. And we can only use this data for specific purposes, which is quality assurance and product development. That's why we use the training data from, and to enable service processes like inform you in advance, hey, there might be something happening. And this data is only accessed by BMW employees with valid use cases on a need-to-know basis. You can't just say, I want to have all the data. This is not possible. And we enforce this strictly. So the data we have, which we then ingest on our data lake, we do this with Glue and Spark. That's the same serverless paradigm we use, which is one of the reasons why we use Athena so much, because with Athena we can do ad hoc exploratory data analysis. Have a look at this car. Hey, there's a new car, and something looks really strange. Let's get into more detail with that vehicle. And to really ensure privacy, a really nice feature of Athena, which we're using, or which, I mean, it's inherently used, is that the link of Athena with Glue ensures that what I mentioned on the slides before is really enforced. That means you cannot really, by accident, check in another data source and say, yeah, that's something I found out. All right, machine learning. Again, I said we only use the data from customers who opted in. And this data, one of the things where we do feature engineering is we de-identify the data for training. That is, no engineer at BMW who works with the data to build a machine learning model has any access to customer relatable information. So the vehicle identification number is hashed with a specific function, so we do not know to whom the car belongs. This is how we train. Then, to identify the unknown service problems, we use anomaly detection to find out, hey, does this car behave regarding some features differently like the other cars we have? And after this, we start with a machine learning model. I mean, some of you guys might know the confusion matrix. As said, it doesn't really help us to go for the normal accuracy, so we focus on precision and sensitivity. And precision is how many of those service demands we predicted were really correct, and what of the proportion of the service was really predicted correctly. So this is like how we really train our models on. I mean, there's a lot of other things we'll do but that would be like almost like a known talk. So I just mentioned this briefly. And the real-time monitoring, the fleet, we visualize with QuickSight because it's easy to maintain. We used to have like a specific backend solution running on AngularJS, but this was really more difficult to maintain, especially when we adapt it to other use cases. We do the inference in real time, and we use Athena to pipe the data and the predicted and the model we use on each vehicle, we pipe this with Athena into QuickSight, so our engineers in the backend know, okay, this is some car we should have a look at before we identify, for instance, the dealers. All right, if I might sum up like all the challenges, how we solve it, we got a scalable data lake, which has assets covering the whole life cycle of all the vehicles in our fleet and their parts, of course, de-anonymized. Then we do some data analysis on them. We build machine learning model with focus on precision and sensitivity. And we have a real-time monitoring with QuickSight. And this is all where Athena shines for us, because we can use Athena to have a scalable serverless. And serverless is really important for us, because otherwise we would have hundreds of EC2 instances running the whole time. So, on a whole, why do we think is this so great? Because, to the best of my knowledge, this is like the first end-to-end workflow in the whole automotive industry, from generating the data, doing a data-based or AI-based identification of a possible service demand, predict this, and now go one step more and not only say, yeah, this is something the customer could have a problem, but just really ensure to solve this issue. It doesn't really help you to know that there could be something happening when you can really help the customer. It's a fully serverless, scalable cloud infrastructure, which we can adapt to our growing fleet, and it's built 100% by BMW engineers on AWS infrastructure. And the last slide, why do we think what are the benefits? First, from BMW, as mentioned, cost-efficient, scalable. We can grow it to the fleet. And we have like a tool chain, a workflow to identify service demands before it's really happening. And this is really, really, really essential and vital for us. We get direct customer feedback because we know what happened in the field. By the whole approach, we also hope that we'll improve our customer loyalty because, as said, we think it's really a customer expectation that you do something like this. That's why we made this. I mean, it's not really nice to have a service demand. That's why we want to make it as seamless as possible. Contact the customer in case of demand by his preferred channel. That could either be displaying it into his vehicle, call him by phone for some guys who are really more into that, or just via social media. And by contacting him, also directly offering him a seamless workflow to get this stuff solved. And if I might just really phrase all what I've been showing you in the last minutes in one sentence, it's our goal is the ultimate customer satisfaction through best-in-class customer experience. Or relax, we care. That's from my behalf. Thanks a lot.
So thank you, Jens, for that great overview of BMW's proactive care workflow. It's been really great to see how BMW has been able to use the vast quantities of data available to them and combine that with the power of AWS and Athena, along with machine learning techniques, to really be pioneers in the automotive industry in providing this exceptional customer experience. So thank you, Jens. Next up, we have Cynthia Pekron from Morningstar, and she's going to talk to us about how Morningstar are using AWS and Athena to innovate and scale their highly regarded analyst ratings. So over to you, Cynthia.
It's great to be here. It's an act of God, actually, after my flight yesterday. I'm the head of product management for Morningstar Inc. My team builds all our analytics and new data sets. If you're not familiar with Morningstar, we're a 12,000 company globally. We're headquartered in Chicago. And sorry to disappoint you, we're not the alternative breakfast sausage company. We are a financial data, software, and services provider. But the size of our data probably doesn't match your idea of our folksy Midwestern profile. We process more data in a week than Twitter processes in a year. And investors use our ratings reports over 150 million times per month. So scale is the name of our game. Today I'm going to explain to you how we use the scale and flexibility of Athena to get to market quickly in a highly regulated environment and in ways you probably haven't thought of before. Morningstar is known for our ratings. We rate equities and managed products. Today I'm going to focus on managed products. Managed products is more like funds, if you're not familiar with investing. And so we have a very privileged relationship in the industry. We're an objective provider, so you can't pay us to get a good rating the way you can't ask the Wall Street Journal for a good review. These ratings are on a scale of gold, silver, bronze to negative. And this is how they appear in our reports. We rate across these 5 pillars: people, process, parent, performance, and price. We think those are the areas that investors need to focus on when they select investments for their portfolios, from either an individual investor all the way to institutional. These ratings are very important. So as I mentioned, we're sort of the industry watchdog. Here's an example. Robbie Greengold was not going to win a popularity contest when he wrote this report. He first covered ARK in 2021. In 2020, the assets in this investment had more than quadrupled, and all of the bets were on it. You can see that red line is where he first provided his rating and assessment of the fund. And he was really concerned about how the money was being managed. But you can see at that time, it was still doing very well. The fund later tanked, and it tanked far worse relative to market than even we've seen in the rest of 2022. This demonstrates how efficacious and important these ratings and reports are to the industry. But they're very artisanal. We call the portfolio managers and spend hours analyzing their investments and strategy. And so we needed a way to scale this, because there's more than 3,000 new share class inceptions every month since 2002. And we're on track to have more than 1 million managed products by the year 2025. So a few years ago, we created what we call the Morningstar Quantitative Rating, or MQR. MQR is a human-in-the-loop machine learning system, and it relies very heavily on our analysts' decision-making. So I showed you those 5 pillars. 72% of MQRs receive one of those pillar decisions from an analyst. So it's truly a human-in-the-loop model, and we can ensure the quality. These charts should generally sort on a perfect slope, showing which investments are most efficacious for investors. It's a forward-looking rating, so it's not just based on previous performance, it's how we think these investments will do in the future. So this rating system has been so effective, and we've been so proud of the results, that we're actually combining our analyst rating and our MQR into a single data point this spring. But there was some hesitancy around the MQR, despite its great track record. And initially, we thought it was the opaqueness of having machine learning or AI involved. But it wasn't the random forest. We actually learned that it was the lack of transparency because we didn't have the text to accompany the ratings the way that we do for analyst ratings. So we knew we needed to create an auto-generated text solution, and we needed to do it quickly. This is sort of a challenge for us, though. We had many disparate databases across the company, so we lacked a lot of the data access, even to our own proprietary data, and we certainly couldn't join with some of the other interim calculations we had. We needed to move very swiftly, so it was sort of an acute problem for us. And we need to be able to experiment, so we were kind of worried about some of the structured data stores that we had on-prem. We needed to treat our text as data, so there are maybe 7 to 10 different narratives for each of those managed investments. And we're looking at a large universe size, as I mentioned. And then our text is considered a rating. So we're highly regulated, and so we need a way to interact, store, and manipulate our data in a way that our compliance team was comfortable with. This is an example of why or how scaling this text relies on data. This is an image that demonstrates Shapley values. If you've not taken college math recently, Shapley values show attribution. So they show how positively or negatively each of these data points are impacting the pillar score for this managed investment. We rely on these to then force which narrative through some tree logic we'll be selecting. It requires a ton of data parallelization, and not only for the numeric data that's pushing this, but likewise with the text. We could not just put this, use a generic NLP solution on a large training set because we needed to do it in a regulatory compliant way using data to force the solution to show that we had a reasonable basis for our rating and how we're explaining it to investors. So we had to get our act together on the data, and thankfully we did. So Morningstar centralized its data using Athena. We put 2.5 petabytes of data, 40,000 tables. We have roughly 1.8 million tests running on those tables daily to monthly. And this finally gave us access to, as I mentioned, a lot of our proprietary data, and we were able to finally join with a lot of our own data sets. We needed that flexibility, so we could quickly spin up Athena databases. We didn't have to fool around with making the primary keys match to be able to join, and we were able to really experiment with a lot of the data and how it would impact the text that we got. And then also very important, we needed to integrate with a lot of other Amazon Web Services since most of our other systems rely on these services as well. You'll see here on the far left is our, that's your left, is our on-prem code. It comes in and we spin up some Docker images. We're using ECR. Fargate manages how much compute we need. Here, I'd love to point out the step functions. We rely on those pretty heavily for managing that parallelization that I mentioned. It allows us to isolate in production the issues we're having, and it's helpful for our model validation team and our DevOps team. But kind of centrally important there is Amazon Athena. You can see down in the center. That's where we're pulling up a lot of the data from the rest of the company. We're able to interact and store with our third-party vendor, Wordsmith, where we generate a lot of our text. And then that Quant S3 bucket is from the math nerds. And they can all come together and be queryable through Athena there. So we were able to put out this solution on 150,000 share classes. For some context, analysts are able to cover about 40,000 annually. We cover 150,000 monthly. It took us about 24 months to put together this solution, which sounds maybe potentially like a long time, but we've been able to use it as a template. So last week we put out our sustainability summary, which is contextualized text around 200,000 share classes, and it's on our ESG data, which is environmental sustainability, social and governance data, if you're not familiar with that term. Really contextualizing for investors how much risk an investment has in those sort of three buckets. And we were able to make that solution in under 6 months. So we began the research just in June or July. So we're really pleased with the speed and swiftness we've been able to capitalize on using these solutions, and we intend to expand on these capabilities. Lastly, I mentioned regulation. So we're highly, highly regulated. We really rely on that, the immutability of our data. We love having the multiple region access and confidence there. And then Athena's allowed us to query and make some of that transparent. This is a client-facing Jupyter notebook that uses Athena to query, and it demonstrates over time how a rating or pillars have changed within a rating. So it's allowing investors to look closely, and then we have iterative or other iterations of this notebook available for our model validation team. Gives us a lot of confidence in these types of solutions, which I think even 3 to 5 years ago, we might not have considered using for something as highly regulated as our ratings. So today, I've given you the scoop on how Morningstar thinks about using Athena to leverage for scale, coordination with other Amazon services, and its high fidelity. We were stunned with how we could use it for our tech solutions. If you're interested in joining our team to help empower investor success, we'd love for you to consider it. If you're an investor, we hope you'll use these state-of-the-art reports that can be found on Morningstar.com to evaluate your managed investments or equities. And lastly, I challenge you to think about what areas of your business Athena might be able to transform. Thanks very much.
So thank you, Cynthia, for those great insights into how the Morningstar team is really leading the way in the fintech industry by using AWS and Athena to innovate and scale your highly regarded analyst ratings and empowering and driving investor success. So next up, we have Ravi Pilala from Intuit, and he's going to talk to us about how Intuit has been able to enhance customer experience and engagement through real-time personalization by using AWS and Athena. Over to you.
Good morning, everyone. Good morning. Okay, let's do a small exercise. I'll be asking you to briefly jump into a time machine back to the first time ever. It's fun. Whoever wants to play along, please close your eyes. Don't worry. Remember a moment when you are trying to file your taxes for the first time by yourself. Remember how overwhelmed you are filling out all those boxes. And you might have called your parents or your friends, or some of you even might be looking for the help in Yellow Pages. And also remember, when you received your tax refund, that check, how amazing that felt. You can open your eyes. Thank you for playing along. You're not the only one. Most of the Americans feel the same way. And even I felt it when I came to United States 16 years back. Even back in India, it's the same feeling. It's confusing. Let me tell you a fact. Most of the Americans receive their biggest paycheck in the form of tax refunds. Today, I'm going to talk about why Intuit customers are so confident using Intuit services like TurboTax, and how Intuit data workers and AWS services making that happen. Before I jump into the details, a little bit about Intuit. Intuit is a global financial technology platform that powers prosperity for the people and communities we serve. At the heart of our work, we focus on delivering 3 fundamental benefits. You can see the center of the globe. First one, helping our customers to put more money into their pockets. Second one, eliminating the work, saving time, so that our customers focus on what matters the most. Third one, ensuring that they have a complete confidence in every financial decision they make. Our strategy to achieve these bold goals by creating an AI-driven expert platform where we and others use technology to focus on delivering for most pressing customer problems and deliver awesome experiences. Let me ask you a question. When you are shopping in any e-commerce website, you might have encountered a chatbot. Please raise your hands, many of you. Let me ask you a question. When you are filing your taxes through using TurboTax, you might have encountered a chatbot too. Yes? Okay. These chatbots are not coming randomly showing up in the TurboTax pages. There is a science behind it. The chatbots are trying to understand the customer behaviors and figuring out whether the customers needs the help or not, and pop up those bots when the customers needs help. This is one side of the coin. The second part is we need to make sure that when the customer clicks on the chatbot, redirect those to a right tax specialist. Last year alone, approximately we have a 50 million unique tax filers used TurboTax to file their taxes. 50 million unique financial stories. Everyone's story is different. We have to make sure that the tax specialist is experienced in dealing with those kind of financial stories. So there is a matchmaking happening there. There is a science behind that. To make all this seamlessly work behind the scenes, our data workers are preparing the data in real time, making sure that all these things are covered. To make our data workers successful, we need to provide the infrastructure. Before I jump into the infrastructure part, let's see who the data workers at Intuit. Going from right to left, the BU developer who is collecting the customer's data and trying to ingest their data into a data lake, where the entity data steward are making sure data is clean and understandable for the downstreams. And our data engineers uses this transactional data, converts into aggregates data insights, and make sure that data is readily consumable for data science and business analysts with the quality. Our data science, which we are talking about, bots, right? So they need to create models and make sure that the models are predicting properly when the customer needs help, and they need a quality data. And then the business analyst, they are the ones trying to build the dashboards for the KPIs, for the new features and products which we are adding to the product. To make our data workers successful in delivering for our customers, we need to provide an infrastructure. Let's look into it. A couple of years ago, when we initially migrated to AWS Cloud, how that architecture is. I can't live without the boxes as an architect. So let's see this. This is not different from any industry data lake architecture. We have multiple microservices capturing the data using RDBMS and OLTPs. We have behavioral data is being captured through a Kafka clusters, event domain events, and we receive a lot of third-party data. All this data is being streamed or batched, depending on the kind of a data, into a data lake. Our data lake is nothing but data is sitting in S3 buckets, and then metadata is maintained in MySQL metadata store. We used to have an MPP, and then all that data is ingested using AWS EMR clusters. And a lot of processing used to happen within the MPP. When I say processing here, the processing is creating those featureizations, aggregates, or data insights, which data science and analysts needs, data workers needs. Once that process is completed, data workers directly consume that data from that MPP. There are situations where the data workers tries to access the data lake data through EMR clusters. There are two major problems with this architecture. Because of the MPP's limited compute power, when that processing needs to happen, we need to provide a resource allocation. So we created a resource pools, kind of a floodgates. When the processing happens, shift all the resource pools to processing ETLs who are creating that featureization. And then once the processing is completed, give the resource pools back to data workers. That is slowing them down, because when the processing shifted out, queries are executing more and more longer times. When the data workers try to access the EMR clusters, data through an EMR clusters, most of the time their queries are waiting in the queue in ANT Resource Manager. We decided to modernize this architecture a little bit. We applied two major principles. One, separate the compute and storage, and make sure we lean towards AWS native services. The left side and right side remains the same, middle part what we changed. So if you see the bottom box where the ETL processing happens, most of the data insight generation, aggregates, or featureization happens through a transient EMR clusters or AWS Glue or Redshift ETL clusters. And then generated data is pushed back into a data lake as 3 buckets. And the same data can be accessible through Redshift reporting clusters or AWS Athena. Let's zoom a little bit into AWS Athena aspect there. So data comes, someone makes a call to AWS Athena, it calls data lake data and then executes the data. What's different in there? It's common. Because of legacy reasons, we have to use MySQL-based Hive metastore. We are not using Glue metastore here. We need to do a special setup. That special setup is not that complicated, but it is something we need to do differently. Let's look into that. When the call comes to AWS Athena, it calls a Lambda function. The Lambda eventually calls the thrift server on AWS EMR, which is a tiny EMR, persistent EMR, which automatically connected to our Hive metastore. It provides all the required information to Athena, and Athena's execution engine knows which S3 bucket to pull the data from, and it executes that via Presto engine. Some of the features which our data workers heavily use, dependent on Athena's one. Because of the sensitivity of the data, what we deal with, we encrypt the data using our own algorithms. So we have to, whoever have access to decrypt that data uses Hive, the UDFs, which is internally a Lambda function. And then a lot of joins, repetitive joins are there across the board. Only in tax domain, we have 20,000 views are there. That gives you a complexity around it. So our data workers uses those views to query the data. Federated query. We still have a small MPP cluster in the environment. We are not able to get rid of yet because some of the applications not migrated. To join that data with the data lake data, we are using the federated concept. So we don't have ETLs to move the data between. We are planning to use the same feature to query the data between a BigQuery and our data lake data. I'm waiting for come that to a live. It is in the design phase right now. And the last but not the least, every data worker wants to use their favorite tools. They don't want to compromise that. Because of the seamless integration of Athena to any kind of a tools, data workers are easily adopted Athena. Let's see the usage matrix. During a tax season, we have 250,000 queries executed per day. And then those 250,000 queries, average execution time is 10 seconds. This is a very big thing for us. Think about it. Terabytes of data being scanned for every Athena query execution, and still we are getting in 10 seconds response. They don't have to wait their queries in the queue. As remember, I was mentioning that most of the queries are waited for the queue in the EMR and resource manager. Because Athena's serverless feature, they don't have a queue mechanism anymore. And this is a huge thing for our data workers. That said, how does that really help our data workers? When we measured last year, data workers' performance. It saved 1 hour a day. What I'm going to do if I have extra 1 hour a day, our data workers try to spend that 1 hour, fine-tune those models, understand more data insight, understand where our customers needs more help. That's where they focused on. That last year alone, our model performances overall increased by 4 times. We are not only focused on the chatbot. Across the product, different workflows, our data workers focused on using the real-time data to provide the more personalization for our customers. And finally, I'm going to conclude with leaving you with the 3 points. 1, helping whatever the work we are doing to make sure that we are going back to our customers by helping to put more money into our customers' pocket, eliminating the work and saving their time so that they can focus what matters the most, and ensuring that they have a complete confidence in every financial decision they make. I'm very proud what we delivered for our customers. This is not the end. We are continuously trying to improve with the help of AWS services. I can't envision the same thing what we delivered with any other options. Thank you.
So thank you, Ravi, for that great overview on how Intuit has been able to enhance customer experience and engagement through real-time personalizations, all powered by AWS and Athena. So with that, I want to just call out a few things that we heard today. So what we heard today is how AWS and Athena are powering BMW to be leaders in the automotive industry through their proactive care workflow and providing a first-class experience for their customers. We heard how AWS and Athena are powering Morningstar to empower investor success at scale through their highly regarded analyst ratings. And we heard how AWS and Athena are powering Intuit to provide a great tax filing experience through real-time personalizations. So with that, I want to thank our customers for sharing these exciting initiatives that are all powered by AWS and Athena and showing us how they're transforming for their customers, businesses, and industries. So with that, as we bring the session to a close, I do want to point you all to Athena's website, which has loads more information about Athena. I also want to point you to other reInvent sessions that are happening on Athena this week. We have 2 more breakout sessions, What's New in Amazon Athena, and Build Interactive Analytics applications. And we have 2 more Chalk Talks, Modernize Your Analytics Architecture with Amazon Athena, and Build Transactional Data Lakes using Open Table Formats in Amazon Athena. So I think we will have a few minutes for Q&A. But I just want to thank you all for being here. It was great to be here with you. And I also want to point that we have this email, Athena support@amazon.com. So feel free to reach out to us with your questions there also.